Okay, now we'll continue with our class on activity. So now we'll see the dependence of activity on temperature and pressure. First, let's see the variation of activity with temperature. Chemical potential in terms of the activity, we can write mu I is equal to mu I0 plus RT ln AI. Dividing this equation throughout by temperature, we get mu I by T is equal to mu I0 by T plus R ln AI. Taking mu I0 to the left side, mu I by T minus mu I0 by T will be equal to R ln AI. Now we'll differentiate this equation with respect to temperature at constant pressure and composition. That is dou by dou T of mu I by T minus mu I0 by T, which is at constant pressure and composition. R being a constant, we can write R into dou by dou T of ln AI with constant pressure and number of other components, number of moles of other components. When we were deriving the variation of fugacity with temperature, we had obtained an expression dou by dou T of mu I by T is equal to minus H cross I by T square. This derivation we had done. Dou by dou T of mu I by T is equal to minus H cross I by T square. Here also we have the same expression dou by dou T of mu I by T minus dou by dou T of mu I0 by T. So we'll use this substitution. So this equation now becomes minus H cross I by T square minus of H cross I by T square. That is, this becomes plus H cross I 0 by T squared is equal to R into dou ln AI by dou T at constant pressure and Ng. Okay. So now let's rearrange this equation and we can write Hi0 by T squared minus H cross I0 by T square into H cross I by T squared is equal to R into dou ln A by dou T at constant pressure and Ng. So what are we trying to do? We are trying to find the variation of activity with temperature. That is dou ln A by dou T. So writing this equation in terms of dou ln A by dou T at constant pressure and Ng, we'll get it as H cross I0 by T squared minus H cross I by T squared divided by R. Now this we can write it as H cross I0 minus H cross I divided by R T squared. So this equation gives the variation of activity with temperature at constant pressure and number of moles of other components. So what is H cross I0 minus H cross I? Hi0 is the enthalpy of pure component, and HI is the enthalpy of component in solution. But for an ideal solution, when a substance makes an ideal solution, the change in enthalpy on mixing is 0. Therefore, the change in partial molar enthalpy on mixing will also be 0. When an ideal solution is formed, the change in enthalpy of mixing is 0, the change in volume on mixing is 0, and hence the change in partial molar property will also be 0. That means dou ln A by dou T at constant pressure and Nj is equal to 0. What does that indicate? Activity is independent of temperature. Unlike fugacity, activity of a component in a solution is independent of temperature. Now let's move on to variation of activity with pressure. Again, we'll make use of the equation for chemical potential. Mu I is equal to mu I 0 plus RT ln A. From this, what is mu I by mu I 0? Mu I minus mu I 0, that is equal to RT ln A. So what is ln A? ln A is mu I minus mu I 0 by RT. When we are considering the variation of activity with pressure, we'll keep temperature a constant. So R and T are constants. Now the variation is dou by dou P of ln A at constant temperature, and number of moles of other components will be equal to R is a constant, T is a constant. Therefore 1 by RT we can take outside, dou by dou P of mu I minus mu I 0. This we can write as 1 by RT into dou mu I by dou P minus dou mu I 0 by dou P at constant temperature and Nj. What is dou mu I by dou P at constant temperature and Nj? We have already derived it as equal to partial molar volume. Hence, this equation now becomes dou ln A by dou P at constant temperature and Nj as equal to V bar 1 by RT into V bar I minus dou mu I 0 by dou P, dou P at constant temperature and Nj. Okay. For standard state, we have dou mu I 0 for standard state, pressure is 1 atmosphere. Hence, this term becomes insignificant. This term becomes insignificant since for standard state, pressure is taken as 1 atmosphere. That means dou mu I 0 by dou P is a constant. That becomes 0. So what we have left is dou ln A by dou P at constant temperature and Nj is equal to V bar I by RT. And now this equation gives the variation of activity with pressure. Activity is independent of temperature, but it varies with pressure as per the equation V bar I by RT. So now we have completed activity and activity coefficients.